So now the goal of this video is just to kind of get an idea of how efficient this power supply is. So it's AC to DC right there. So I have my portable generator right here. First thing we need to do is turn it on. And this one you have to give it a quick press of the button to turn it on. If you just hold the button, it won't turn on, and you may be confused why it didn't turn on. At least I was. So now, the other thing with this power supply, it looks like DC is already on. We have to hit the AC button to get the AC output to turn on. And now that we have the AC output on, and I'm going to be careful, I was powering that resistor a little bit ago, and it's hot. So I'm going to grab the wire and not the resistor. So we're going to plug in the power supply right there. You will see it turn on, and you can see that the power supply here, the power bank I should say, needs 2 watts of power just to power the power supply right there. So now this is a 6 ohm resistor. If we put 6 volts across it, that says 5, we'll get 1 amp of current. That will be 6 watts. It's also a 50 watt resistor right there. So we can go up to about 25 watts. But we're going to start off with 6. We're going to need more than 20 milliamps of current, which I normally set there. I'm going to set it to the max that this power supply will provide. Output is off right now. So now I got the resistor off the plastic, hopefully completely off, because it will likely melt it due to how hot it gets when we get it really hot. So doesn't matter with polarity. Put positive on one side, negative on either side, I should say. Positive on either side, negative on either side. And again, the power supply is off, so no power is being provided. Now that I turn it on, interestingly enough, we got 6 volts, but only, or that's voltage, never mind. I thought that was a current. That was really weird to see 0.6 there. But in any case, there we go. A little less than 1 amp. But in case 6 volts plus 1 amp is 6 watts. So there you can see we got 9 watts there. But remember, this needed 2 watts just to power it. So we're probably only losing about a 1 watt of power in the conversion. And now I'm going to bump this up to 12 volts right there, which is going to be about 24 watts. So it looks like we're a little bit lower on the current right there. This might not be exactly 6 ohms. I'm guessing it's slightly above right there. They're not meant to be precision. But in any case, there you can see 12 volts, 2 amps, that's 24 watts. This kind of ticks down to 28, but I think it's probably like close to 29. I saw 30 before in the testing. Maybe if, you know, make a slight connection difference, maybe it will change. But in any case, 24 watts in, and in this case it says 29 watts out right there. So remember, we got 2 watts that this unit is just to be powered on, and then we have, it looks like 3 more watts on top of that right there that we are losing in the conversion. But in any case, this isn't a terrible way to, you know, power something else with the energy in this battery. And the reason why I would do this, we have a 12 volt DC outputs, but that's it for this particular power supply. And I'm trying to find a good voltage booster to do something similar here with the 12 volts. But then there's other issues. So the reason why I'm doing this, it's not powering anything right now, is that we can bump this up to 30 volts right there. But the current goes down to a maximum of 1.6666. So we got a little bit more than 45 watts of power we can provide here. But at 30 volts right there, we need 3 watts to power this unit. And this resistor will get really hot at this point. In fact, no, it'll pass more current than this can provide at this voltage. So we're not going to continue on with this anymore. But in any case, I turn the power off, and that's the output off. I think I actually have to unplug this unit to outright turn it off. So we're actually going to do that right there. This will not turn off though. Sooner or later it's going to drain the battery. You know, not super fast. I don't think we have to press AC there. But now to turn it off, you hold the button down and it turns off. So in any case, I just wanted to get an idea of how much power I lose powering this from a battery source. So this inverts it, which is also going to have power losses right there. Probably much more efficiently if we could take the DC out and work with that. But in any case, this one I can adjust it fully and stuff. That's one thing that I like about it. The DC to DCs are harder to adjust. So in any case, just wanted to get an idea, and thought I'd make a video in case you find that interesting too. So thanks for watching. I'll see you in the next video.